So that's where Savannah got her 1 minus 0 over what? Over n. Is everybody with me? And numbering at number 1, you know, me, I'm probably gonna box it because I don't like looking for stuff in my spreadsheet. But that's up to you. Okay, but it sure makes it easy for me to find. Which, if I'm in a good mood when I give you partial credit, it's not a bad thing. Okay? Now, all right, make sure they can see. All right, step 2 is I'm trying to find this C sub I. So I've got A plus I times delta X. Now, what's my A? My A is what? 0. I've got my I just found delta X to be 1 over n, so we plugged in 1 over n. So we end up with C sub I being I over n. Step 2. We good? Now, what do I do with that C sub n? Step 3 says I take that C sub I and I put it in my what? My function. So I go back up to my function. Here's my function. Do we see my X? Now, what am I putting in place of X? C sub I. So I'm putting in I over what? N. So instead of that X, I put what? I over n. Now, what have I got to do to it? I've got to square it, and I've got to add what? 2. Now, this is 7th grade pre-algebra. This is with the death of us all. Okay? So when I've got a fraction to a power, that power goes with the numerator and the what? Denominator. So I've got an I squared over an n squared. All right, now I just need a what right here? An I squared. So it's not the complex number I. Is everybody with me? It's just a variable what? I. So we're not talking about the square root of a -1 equaling I. Is everybody with me? So the I is just a what? Variable. You could use Z. I don't care. All right, but the book's going to use what? I. Okay, so that's why putting a -1 there is not going to work. All right, so I've got an I squared plus a what over n squared plus a what? 2. So there's step 3. All right, so this is my F of C sub I. Now, what am I supposed to do with it next? I'm supposed to do what? Summation. I'm supposed to do this summation over here. All right, so here's what we're going to do. All right, so we're going to sum from I equals 1 to n. Now, what's my F of C sub I? I go back looking for it. What was it? I squared over what? N squared plus 2. And then I've got to have my delta X. So I go back looking for my delta X. This stuff is step 1. What was delta X? 1 over n. So that's the reason for me boxing stuff works pretty well. All right, because I can find it pretty quickly. All right. So let's go do this. So I'm summing from I equals 1 to n. Now I'm going to multiply. I'm going to do this a longer way just because I want to make sure we got all the little nitpicking steps. I've got to distribute this 1 over n to both of these terms. So I squared times 1 is what? I squared. Now what's n squared times another n? N what? Cubed. Now I've got to do 2. Now what's that 2 understood to be over? 1. So 2 times 1 is 2, and 1 times n is n. So this is what I'm summing. Okay. I go up a little bit. So I'm going to break it up. I'm going to sum from I equals 1 to n of I squared over n cubed plus 2 over what? N. So I'm going to do them separately. I'm going to sum from I equals 1 to n of I squared over n cubed plus I'm going to sum from I equals 1 to n of 2 over what? N. Everybody clicking. Now, what's my variable here? What's changing? All right, I is my variable. So anything else is a constant. What can you do with constants if you want to? Pull them out front. So I'm going to pull this n cubed out front, but it's not on the top, it's on the what? The bottom. So it's not n cubed, it's 1 over what? N cubed. And I'm going to sum from I equals 1 to n. What's left right here? I what? Squared. Now, both of these are variables, but if I pull them both out, what's left? Nothing. Is everybody with me? It freaks everybody out. So I'm thinking about all my formulas. I know what I squared at I cubed. I don't have any i's. What's the other thing I know? A constant. Well, which one of those looks more like a constant? Which one's not going to freak you out to leave? The 2. So what am I pulling out? Not n, but what? 1 over n. Now all I'm going to do is go use my formulas that I've got memorized, which means if I don't have a memorized, game is over. So what's the formula right here? When you sum from I equals 1 to n of I squared, what's my formula? N times what? Look, if you have to in the book, n plus 1 times what? 2n plus what?
1.
All over what? 6. So in your books, let me remind you where it is. Right. Those are on page 295. So if you don't have those memorized, you need to get them memorized. All right, plus, now I've got a 1 over n. Now, what's the formula when you've got a constant? It's just that constant times what? N. Now, the rest of this is 7th grade pre-algebra once again, which is gonna be, like I said, it's gonna be the death of me, all right? I don't care how you do it, how many steps. I'd rather you have more steps and less mistakes. So I'm careless, so I may have to do more steps than you, okay? So n times n plus 1, I'm gonna get n squared plus what? N. And then I got a 2n plus 1, and all that's over what? 6. Now this one I like. What happens to those n's? They divide out. So what am I left with over here? Just a what? A 2. So I've got a 1 over, now here n cubed times 6 is going to be what? 6n cubed. All right, so that 1 kind of, now I'm going to distribute this out. N squared times 2n's 2n what? Cubed. N squared times 1 is an n squared. Now I got to do n times both of those. So n times 2n is 2n squared, and 1 times n is n. Now, I can combine n squared and 2n squared, right? What's that give me? 3n squared. All right, so rather than wasting the marker, I'm just going to go change this to plus 3n squared, but I've still got my plus what over here? Now, I'm gonna put, can I put each one of these on top of n cubed? So I've got a 2n cubed over a 6n cubed. And then I've got a 3, I said, ooh, it's bad. A 3n squared over what? 6n cubed. And then I've got an n over a what? 6n cubed. And then finally I got a plus what? 2. All right, clean this first one up. What does this clean up into? What happens to the n cubes? They divide to 1. What 2 over 6 reduce that? What do I get? So I just get 1/3. That first one just goes down to 1/3. All right. Now, what's the 3 over 6 going to reduce to? 1/2. And then where's my extra n going to be when I divide that n squared out? On the what? On the bottom. So does everybody see where I got 1 over 2 n squared? All right. Now
1 over 2n.
Oh, thank you so much, Nash. 1 over 2n. Now, no, yeah, I do. I'm getting jumping ahead. So this one, what's going to be on the bottom?
6n squared.
A 6. 1/6 doesn't reduce, and I've got an n what? Squared. What do I got left over here? Plus what? 2. Now, can't I combine at least the 1/3 and the 2? What's 1/3 plus 2?
7 over 3.
Yeah, 2 1/3 or 7 over 3. So I'd probably go ahead and combine those, but that's just me. Do you have to? No. But that's as simple algebraically as I can make it. So that's what I mean by step 4 is going to be, it's not hard, but it's tedious. Okay, but I'll take long and easy over short and hard. That's just me there. Now, what's my last step, step 5? What do I do with this answer? I take the limit as n increases without a bound. 7 over 3, 1 over 2n, 1 over 6n squared. Okay, so what's the limit of a constant? Cal 1, what's the limit of a constant?
It's just the constant.
It's just the constant.
Yeah.
Because remember, limit's asking you what the y value is. Well, here the y value is always what? 7/3. We'll talk about that in a second because y'all were staring at me like I lost my mind. All right, now, what's happening when this bottom's getting bigger and bigger? The fraction's getting smaller. See, if n is 10, that'd be 1 over 20. 1/20th. If n's 100, that's going to be 1 over 200. 2,000. Bear with me. So I'm approaching what? 0. What's happening right here?
Same thing.
I'm just going to 0 faster. Because if n is a 10, instead of being 1/60, it's 1/600, you see what I'm saying? So what did I end up with for my final answer? 7/4. Now, if you can do this one, you can do any that I hand you. So what that tells me is if you can do this one, you can't do 53, it's gonna be pre-algebra skills. All right, so let me show you what I mean, and then I'll go back and explain that limit of a constant just to make sure we're good. All right. And do remember when you're at the board, try to write big because at the back it's a little hard to see. Now, delta x, b minus a over what? N. So we got 2 over n. Everybody see where we got the 2 over the n. Now, again, I expect you to know what a cube looks like. What's a plain cubic function looks like y equals x cubed? It's an S curve. Is everybody with me? Now, I'm only going from 1 to what? 3. So do we understand if I put a 1 in there, wouldn't I get 27 minus 1? Which would be what? 26. I'm not going to graph it. I was going to do a rough graph. So if this is 26, we understand that I'm up here. Is everybody with me? I'm going to 3. Now, what's 3 cubed? 3 times 3 is 9. What's 9 times 3? So what am I out to now? I'm out 27 minus 27, those what? 0. So does everybody understand? Is this curve non-negative? Yes. So this is good. This limit process is going to give me the areas. Everybody with me? So I'm covered. All right. C sub I is a plus I times delta x. What's my a? 1. And there is my C sub I. So for C sub I, he got 1 plus 2i over n. Does that make sense to everybody? Now, what's he going to do with that 1 plus 2i over n? Put it in for what? This is where you blew up. Guarantee. Now, there's a shortcut to getting a cubic. But you don't have to know the shortcut. You can just gut it out. No fun, but you know, a lot of life isn't. All right, so I've got, what does 1 plus 2i over n cubed mean? 1 plus 2i over n times another what? 1 plus what? 2i over what? N times another what? 1 plus what? 2i over what? N. That's the way life goes. So if I multiply this one, what's 1 times 1? 1. 1 times 2i is going to be what? 2i. Then do this one. What's 1 times 2i going to give me another what? 2i. And then what's 2i times 2i? 4i squared. Is everybody with me? Well, I can combine those two, so I get 1 plus 4i plus what? 4i squared all over what? N squared. But now I got to do times another what? 1 plus 2i over what? N. Okay. I've got to do this one times both of these. Well, 1 times 1 is 1. 1 times 2i is 2i. All right, now do this one. 4i times 1 is 4i. 4i times 2i is 8i squared. And I got to do this one. Woo! What do I get? 4i what? Squared plus what? 8i cubed. Now all that's over what? Now, what's 2i plus 4i? 6i. 1 plus 6i over n plus what's 8i squared plus 4i squared? 12i squared over n squared. Is everybody with me? I mean, over. So then I'm going to have plus what? This one over what? That one. Everybody okay? Now, what have I got to do with that? I've got to add what to it? I mean, I got to do 27 what? Minus that. Now, all right, so what do we got here? So they all need to be over n what? Cubed, is that right?
Yes.
Is that right? Did you do something to clean it up? Hunter, do you remember? I think they all need to be over n what?
Cubed.
Okay, so now distribute that minus, we're just going to change the signs. Everybody with me? Okay, so he said 27 minus 1 is what? 26. And I'm going to let you finish. I'm not going to take time to finish it. I want you to finish it and see if you can now get the answer in the back of the book. Is everybody with me? But you see, this is the part that you've got to be what? Just a little careful with. It's not that you don't understand the process. It's just you're going to make a 7th grade pre-algebra mistake more than likely. Once you sum it and get it cleaned up, you've either gotta get a number, an I squared, or what? I cube, plug in your formulas, and then when you clean all that up, take the limit as n increase without a main. All right, so does everybody understand the process? Anybody, anybody clear about the process?
I think when we use the formula of a plus b cubed, it does get, like, he did it right.
Okay,
Because like 3a squared b, 3ab squared. So.
right, but what I'm saying is, what you've got to do is I've got to cube the what? The numerator, but I've also got to cube the what? Denominator, so all this stuff on the numerator, they're all over what? In cube. Okay, and see, that's just an easy thing to what? But double check me, see if we made a careless error somewhere, because it's just as possible for me to make one as it is anybody else. Okay? Now, first of all, let me do this, because I neglected to do this the other day. Remember that worksheet that you had on the physics type application? All right, pull that out, so I can tell you what answers I got, so you can kind of check your answers. It's been a while. Okay, and I meant to give you those answers the last time, but I just forgot about it. All right? Had a holiday, and my brain took a holiday as well. Okay? All right, so look at number one on that worksheet. What did y'all get for 1A? What is the ball reaches maximum height? How many seconds did it take for y'all? Two, is what I got, 2 seconds. All right, then for my maximum height, I got 224 feet. Is that what y'all got?
Yeah.
Okay. For C, for the third thing, I got 2 plus the square root of 14. That's the exact answer, and that's what I would want on a test. Now, that's about 5 7/10 seconds. So if you got about 5 7/10, then you're right, but then you go back and make sure you get me your irrational number.
Just the square root of 14?
I got 2 plus the square root of 14 seconds. All right. Then on D, I got a negative 32 times the square root of 14 feet per second. All right, so again, if you went to decimals, that's a little over a negative 119.
Would you add the 64 to that or not?
We'll look at one real quick. All right, look at number 2. On 2A, did y'all get 1.5 seconds?
Yeah.
All right, on B, I got 36 feet. On C, I got 3 seconds. All right, on 4, the D part, I got a negative 48 feet per second. And on E, I got 16 feet per second. Okay, so for instance, on, that one is terrible. All right, how do you get from acceleration to velocity? What do? You integrate.
I have a question about this one.
I'm listening.
Isn't CI 1 plus 2i over n? And why did you put a denominator?
Okay, so the
Okay.
n only goes under the 2.
Yeah, it's only.
Ah, that's what it is. Thank you. So look what I did. I made a 7th grade pre-algebra mistake, correct? So what is it? I miscopied it.
On the left.
Ah, right here. All right, it was 1 plus 2i over n cubed, not 1 plus 2i all over what? N cubed. So go back and fix it the way that we had it. Thanks. Appreciate y'all checking that out. Okay, now, where am I? Oh, all right. So if you've got acceleration, we integrate to get velocity. Does that make sense? Then what do we do again to get position? We do what? We integrate again. Is everybody with me? So I integrate acceleration to get velocity, integrate velocity to get what? Position. So the C part said, when did it hit the ground? How do I find out when it hit the ground? What do I do to find out when it hit the ground? I let the position equal what? 0. All right, what did y'all get for your position function on number 1? You got a what? Negative what? Is it gonna be a negative 16?
Yeah.
All right, either X or T what?
T squared.
Squared, plus or minus?
48.
Plus what?
64.
64 what? X or T, and then plus or minus. Was there anything else? Was that it? Plus 160 equals what? 0. Now, once again, if you don't like big numbers, you can pull something out. What's the greatest common factor between these coefficients? 16, you can pull out a -16 or a what? +16, your preference. All right, I tend to pull out a -16, but that's not more right. Okay, that's not more correct. If I do that, I'm gonna get a t squared, not plus, but I'm gonna get what? -4t, and then what? Minus what? 10 equals what? 0. Now, that either says that -16 is 0, or this thing is 0. Is a -16 ever gonna be 0? So that's not an option, so now I gotta go do that. Okay, so that doesn't factor all pretty, does it? So what can I always use? Quadratic equation. All right, what's my quadratic equation? Negative what? B plus or minus the square root of what?
B squared.
B squared minus 4, AC all over what? 2A. All right, what's my A in this one? 1. My B is not 4, it is -4, and my C is a what? -10. So I need the opposite of B. Well, my B is a -4, so what's the opposite of that? 4. So my B is a -4, so I've got to square it minus 4. My A is a 1, and my C is a what? See, it takes me 3 seconds to write this down, and I could be less careless when I do that. So I've got 2 times, what's my A? 1. So I've got 4 plus or minus, now what's a -4 squared? 16. I'm gonna get not a -40, but a what? Plus 40, and all that's over what? 2. So I've got a 4 plus or minus the square root of what? 56? All over what? 2. Now, you can start thinking of perfect squares that go into 56. All right, so I know 4 goes into it. What do you multiply 54 by to get 56?
14.
You see, that one's not gonna get me anything more, so I've got 4 plus or minus. Everybody okay? Now I can break that up into the square root of 4 and the square root of 14. Well, what is the square root of 4? 2. Now I can factor a 2 out of the top. What's that gonna leave me? A 2 plus or minus the what? Square root of 14 over what? 2. Well, those 2's divide out. So I've either got 2 plus the square root of 14, or I've got 2 what? Which one doesn't make any sense in this context? This one will give me a negative time, so there I got many seconds. Okay, and then it asks you what velocity hit the ground, so I'm gonna take that number and plug it into my what? Velocity formula. So if you need some help with those, come see me. Okay? All right, now, here's what we're gonna talk about today. All right, we're gonna talk about something for just a second called a Reimann sum. Okay, a Reimann sum. Now, I'm not gonna spend a lot of time on a Reimann sum. If you took AP calculus in high school, you probably spent a lot of time on a Reimann sum. But they had you for they had you for a whole year. I've got you for half a year. Okay. All right, a Reimann sum basically is another way your book's going to use to get area. We're going to talk about it. It's basically, here's what a Reimann sum is. This should look real familiar to you. Does that look real familiar to you? All right, here's the difference. They've still got their little eyes, but then they make a big deal over here about this. X is some number between, how do they do their notation? Yeah. They do x sub I minus 1 and x sub I. All right, this kind of goes back to Trevor's question the other day. When we first started in upper and lower sums, we kept using the left endpoint and the what? The right endpoint. And he said, well, could we use them with the midpoint together? And we said, well, yeah, sometimes midpoint's better. What? Sometimes it's not. Now, here's the difference between what we've been doing in a Reimann sum. I mean, there's a little more than this, but this is the big difference. I'm gonna simplify. You know our widths? weren't they all uniform? All of our rectangles have the same what? Width. A Reimann sum doesn't have to do that. On a Reimann sum, it's a better fit when you've got kind of a weird, curve, it can get some weird stuff. In other words, I might decide to make this one real skinny and then, and I might decide to make, this one pretty wide because it looks pretty flat. Then I might decide to make this one, you see what I'm saying? Like, in other words, I can change the widths of the rectangles to try to make it fit the curve better. And I can use any point in the rectangle. I don't have to just use the left-hand point, the right-hand point in the middle. I can use like any X value in there. Well, common sense tells us, would that get you a better approximation? What? Sure it would. Now, on a Reimann sum, the widths can be the same, but they don't what? Have to be the same. So I'm with them. If I've got to go calculate for a particular number of rectangles, like if I have to use 5 rectangles, then I agree, using varied widths would be better. But I'm not really doing that anymore. Is everybody with me? What am I doing with my number of rectangles? I'm increasing without a what? A bound anyway. So I can use various widths, but guess what I'm going to choose to do? I'm going to use something. It just simplifies my process when I'm doing the manipulation. But do you understand on a Reimann sum, the widths don't have to be what? The same. Now, they're going to introduce this notation because I'm going to change something in the definition and stuff. And I want to mathematically at least hand wave as to why I can do this. Okay? All right. This notation, double bars on either side of a delta, means the norm of a partition. Now that just sounds horrible and fancy and intimidating, but it's not. All right. Partition is the fancy math word for divided into pieces. So if I take a shape and I start cutting it, a mathematician won't say I'm cutting it, it'll say I'm what? I'm partitioning it. Doesn't it just sound like you're smarter? You know what I'm saying? Like I'm partitioning it. But what I'm really doing is just what? I'm cutting. All right. So now instead of one piece, I got a bunch of what? Little pieces, smaller pieces. Now with the Reimann, see before when I was cutting it, all my pieces were the same what? Width. Now what? When I'm cutting it, what? That'd be the same width. The norm means the biggest. The biggest piece. And it's talking about width because it says it's talking about X. So in other words, if I'm cutting this, do you see that width? I've got that width, I've got that width. Now if I come over here and make this width, do we agree that this one's the widest of the ones I've got drawn? Then this distance is my norm. Now, here's what they're going to give you for a definition. All right. The definition that I want to kind of get to is on page 308. And here's what you've been doing. These are the kind of integrations that you've been doing. These are called indefinite intervals. What's IN mean? If you're incompetent, what's that mean? You're not competent. So if you're indefinite, it means you're not what? Definite. All right. This is an indefinite interval. So what you get with an indefinite interval is you get a family of functions. You get something that looks algebraic. X squared over 2 plus C. Everybody with me? Now, you can get one function if they also give you an additional piece of information, like the initial velocity is this, or f at 1 is 7. Is everybody with me? But indefinite integrals get you back a function. They get you back an equation, an algebraic looking thing. Now, what we're gonna talk about now is something called definite, not indefinite, but what? Definite, all right? Here's what a definite one looks like. Yeah, I'm gonna go by a little ways. All right. A definite looks just like this, except there's gonna be a number here and a number here. Like 2 to 5, -1 to 8, 0 to the square root of 7. All right, so they're gonna call it an A and a what? B, which look real familiar, depending on what you did last night. You went from an A to a what? To a B. This answer is a number. 11, -pi/7, the square root of 11. All right, so this one's a number, this one is like an equation, like a function. Is everybody with me? I get an expression, not an equation. Is everybody with me? Now, they give you the definition of this, which I am going to ask you on a test, and I'm going to ask you to use it. So make sure that you know it. All right, it's in your books on page 308. And basically, here's what it says. It's the limit as the norm approaches 0 of the sum of I equals 1 to n of f of c sub I times delta x sub I. Now, that should look super familiar to you. Now, it does tell you this, you got some conditions on it. First of all, it says your function f has to be defined on the interval from A to what? B. I mean, if it's not defined on the interval, game's over. Okay? And then it says, and the limit of the Riemann sum, this has to exist. So if both of those pieces are true, this is the same thing as this. Now, what's different about this and what you did last night?
The norm.
This part right here, is everybody with me? What did you have there? N approaches what? Infinity. Now, what's true is this. On these partitions that we are doing, if the widest piece is going to 0, is everybody with me? That always means that n must be increasing without any limit. Because I want you to think about it. And again, I'm kind of hand waving at this, depending on kind of what level we're at, but I think you can follow me. If the widest one, if the widest one's going to approach 0, do you understand what I'm going to have to do is take the widest and cut it? I mean, if I've got a bunch of intervals, suppose this one, it goes from here to here, I'm not drawing a curve. All right, then this one goes from here to here, then that one, remember, because they don't have to be the same anymore. Is everybody with me? So do we understand that this one right here so far is the norm of my partition? These are my rectangles. All right, what do I need the norm to do? I need it to shrink. So I'm gonna have to take it, cutting this one's not gonna help me. Because that's not gonna change the widest one. So what am I gonna have to do? I'm gonna take the widest one and do what with it? I'm gonna have to do what? I have to cut it. So if I cut this one, again, I'm going to cut it in half, I'm just cutting it in half to make a point. Well, now this one might be the widest. So what am I gonna have to do now to make the widest one get smaller? Go to 0, I have to take this one and do what with it? Cut it. Is everybody with me? Now I gotta read back and where's my widest one now? So what I'm gonna end up doing is every time I want to take that widest one and do what? Keep cutting it. Which means my number of rectangles is what? Increasing. So that's why I'm gonna change from this to that. Is everybody clear? So I'm altering the definition a bit to make it fit what you've been doing. Is everybody with me? Now, some professors will just leave it that way and expect you to remember that when the norm is approaching zero, that is the same thing as n's increasing what? To infinity. Now, but let me make this perfectly clear. I didn't say it worked the other way around. Even with what we're doing, does not mean that the norm has to be going to zero. So if this is true, I know this is true, but it doesn't go necessarily the other way. Now, you know this in your real world. Think about it. If a figure is a square, then can you always say it's a rectangle?
Yes.
Yes, that's always true, always. But when you flip it, it's not necessarily true. If you know it's a rectangle, does it always have to be a square? What? No. So sometimes you can't flip your if then. Those are called converses. And converses are not always true. Sometimes they are, but what? Sometimes they're not. This one, the converse isn't true. Now, why does it seems like it would be true? The more rectangles you got, what? But here's the reason it's not true. This is a Reimann sum, which means the widths aren't necessarily what? The same. Now, if we go back to what we were doing last time, if the widths were the same, this would mean this. If all your widths are the same, then every time you have to cut them all, is everybody with me? Then the biggest piece will be going to zero. But think about it. If this is my biggest piece, I can keep cutting. Is everybody with me over here? But is that going to change this biggest width? What? No. See, if I had 1/2 to the n, what happens when n is 1? I'm going to get what? 1, right? What if I was a 2? I'd get 1/2 squared, which is what? 4. Then I get 1/2 cubed is what? 8. I could do that forever. Is everybody with me? But what's the biggest number on that list going to be anyway?
Yeah.
It's always going to be what?
Oh,
1/2. So I can keep going into infinity, but the biggest piece is not ever going to be shrinking. So that's why this one doesn't imply that one, but that one implies what? That one. Now, all that to say, here's what's going to be happening on your homework. They're going to ask you, so in essence, you're going to be doing a lot of what you were doing last night, occasionally with a twist. All right, so what do I mean by that? What is she talking about? All right, the example they give you in your book is this one. Well, let's do this one first, and then I'll go back and do that one. Suppose they tell me to integrate from 0 to 1 of 2x dx. The first thing you're going to need to do is I want you to graph it. All right, because I'm gonna make a big deal about area and integrations. All right, so what's your function? Your function is f of x equals what? 2x. All right, so f of x is like y, right? So what is that graph? That graph's a what? A line. So I told you to go from what? 0 to 1. So we understand at 0, I get 0. And at 1, I get what? 2. So there's my graph. I'm putting it in a different color. It's too orange. All right, so there's my curve. Now I'm going to go, how am I going to do this? 5-step process you had last night. Because that's the same thing as the definition of this. Is everybody with me? So what am I going to do first? I'm going to find what? Delta x. B minus A over what? N. What's my B? Remember, this is your A to your what? B. So I've got 1 minus what? 0 over what? N. So what's delta x? It's 1 over what? N. There's delta x. What's my next step? I find what? C sub I. All right, what's C sub I? A plus what? I times delta X, what's my A? 0. I, what's my delta X? 1 over, so I get I over. Everybody tracking with me? What's my next step? F of what? C sub I. So I take this and put it in place of X. So here's my X. So what am I gonna have? 2 times what? What's my X? What am I putting in for my X? I over N. So what's that get me? 2I over N. There's my F of C sub I. What's my fourth step? That's that long one, isn't it? So I'm gonna sum from I equals 1 to N of F of C sub I times what? Delta X. All right, so I'm gonna sum from I equals 1 to N. What's my F of C sub I? What did we agree it was? 2I over N times what's delta X? 1 over N. So I'm gonna sum from I equals 1 to N of what? 2I over what? N squared. All right, what am I gonna pull out?
2 over N squared.
2 over the N squared, do we agree? All right, so I've got 2 over N squared. What am I summing from I equals 1 to N of just what? I. All right, help me out. What's my formula? Because I don't remember
N times N plus 1.
it. Over?
2.
Perfect. So do we understand what's gonna be on the top? A 2N squared plus a what? N times 2 is gonna give me what? 2N. What are both the questions?
Why do we not just cancel it there, like the N?
You can, that's what I'm saying. I'm just doing way more steps. You understand what Sheila's asking, he's gonna divide that out. All right, what are both of those gonna be over? 2N what? Square. All right, what's this clean up into? 1. What's that clean up into? 1 over it. That's as good as I can make. Now, what am I gonna take the limit of? What's my fifth step? To take the what? The limit. All right, so we'll come up here, so I gotta switch I'm taking the limit, then it approaches infinity of what? 1 plus 1 over N. So what's the limit of a constant 1? The constant. What's the limit of 1 over N as N gets bigger and bigger?
0.
So what's my answer? Is everybody okay? So this definite integral, what's the answer to this definite integral? It's just what? 1. Now, this is a separate question. They are not the same. What's the area between that curve and this x-axis down here? It's also 1. Why? Because this curve is non-what? Negative. If this curve is non-negative, then that definite integral is going to be the same thing as the area from that curve down to the what? X-axis. That answer will not always be the area. Here's why. Suppose instead, is everybody with me? That instead of going from 0 to 1, what if it had gone from -2? This is what your book does. From -2 to 1. What would the difference be? Right here, I would have 1 minus a what? -2. We agree? A, B minus what? A. What's minus and negative the same thing as? So what is this not going to be? It's not going to be 1 over N, it's going to be what? 3 over N. So this would be a what? 3 over N. So this will be a what? 3I over N. Now, let me show you. Go ahead and write this on the board and we'll come back and finish that. But I'm starting to run low on time. And I want to get this in your notes. Then we'll talk about it. This is the one that they finish out in your book. All right, so look on page 309. I'm not gonna take time to do it, all right? Now. But I do wanna make sure we're clear. This is 3/n. What's your C sub I gonna be? What's your A now? It's not 0, what is it? It's a -2. Is everybody with me? So that's gonna change everything all the way down. Is everybody with me? Now, they worked this in your book on page 309. Look at their answer. What's their answer? Can that be an area? No. Why not? Because area can't be what? Area can't be negative. So I do not want you to think that a definite integral is synonymous with area. It's only synonymous with area in one case. What is the one case? When the curve is what? Not, in other words, the whole curve is either touching or above the x-axis. So your book just kind of hand waves at that, but we're not going to hand wave at it. We're going to write this down in your notes. And it's going to make way more sense later, I hope. But I think, in my experience, this cuts down on mistakes later. All right.
I got a rant, a question.
Okay.
So like, if you took what they plug into the limit, which is -12 plus 9 plus 9 over n.
Right.
That's where like they get the -3.
Right.
If you were to take that and do the absolute value.
No, and I'll show you why. But it's a good idea. It will work in an instance, but that's what I'm about to show you is the instance.
Okay.
Okay. If you've got a definite integral from a to b of f of x dx. All right, this could be positive or negative or 0. That could be what? Positive or negative or what? 0. Normally, this number is smaller than that number. It doesn't have to be, but that's standard procedure. Okay. This is exactly the same thing as the area between y equals f of x and the x-axis. If f of x is, what was that word? Non-negative. In other words, the whole curve is above the x-axis or touching it. So they are synonymous if that's the case. Now, if y equals f of x is non-positive. Now, that freaks people out. Do we understand that non-negative, I mean above the x what? Axis. And I'm going to put or touching. Does everybody understand that that gets me to 0? Now, what would non-positive mean? The whole graph is either what? Below or what? Touching. All right. So the graph is below the x-axis. And again, you know, or touching. And here's what's true. If you do this integration from a to b of f of x dx, it's going to be the opposite of your area. And by the area, I mean the area between the curve and the what? X-axis. So if I went from -2 to 0 of f of x dx, do we understand that my curve's down here now? So if I do this integration, it's going to come out to be negative. So if this answer was a -4, this goes back to Hunter's question, what's my answer going to be? +4. Everybody clicking. But this is if the whole curve's above the x-axis. This is if the whole curve's what? Below the x-axis. Well, the one in your book that I kind of started and stopped and said you can look at the conclusion in the book because they worked it all the way out to you. Parts above and parts below. All right, so let's just phrase it this way then. If part of the curve is above the x-axis. And part of the curve is below the x-axis. Now, let me show you what I'm talking about on the picture. I'm integrating from -2 to 1 of 2x dx. This is the one that's in your book that we just talked about. All right, if I were to draw that, what happens if you put a negative, if this is your function, y equals what? 2x, right? So what happens if you put a -2 in there?
-4.
I get -4. So I get from here to here. Now, what happens if I put a 1 in there? What do I get? I get 2. So here's my curve. It goes through the origin. Let's make it look a little better. So do we understand that part of my curve is below the x-axis and part of my curve is what? Above it. If that's true, then the integration from a to b of f of x dx is going to be the area above the x-axis minus the area below the x-axis. Now, let me show you something. What do I mean by that? What I want to make clear, if I make nothing else clear today, is the definite integral always going to match the area? No. Now, later in the next chapter, they're going to find a way for you to deal with that. Today, you're going to have to use your understanding of these three things and a lot of geometry. See, if they really wanted this area, I wouldn't use calculus at all. What would I use? Geometry. Why? I can give that to a 7th grader and say, find that yellow area, and they should be able to do it. And they don't know calculus. What are they going to do? They're going to find the area that's what? Triangle. And they're going to find the area that what? And what are they going to do? They're going to what? They're going to have to get it. Game over. That's what I would do on a calculus test, by the way. But that's not what they're going to ask you in the book. They might, and I might ask you that on the test. Now, suppose you want to be fancy and you want to do calculus. Great. How can you find this red area right here using calculus? In other words, do we understand that I'm talking about from here to what? To there. What calculus thing would find me this area? Isn't that curve non-negative? Then I can integrate what would my a and my b equal. Those are x values.
0 to 1.
0 to 1 of what? F of x what? In other words, my what? My 2x. Everybody with me? Now, nobody in their right mind is going to do that right now because you got to do a whole 5-step process. Next time I'm going to show you a shortcut. You don't do that anymore. Okay? But you could. Now, this kind of goes back to Hunter's question. How are you going to use calculus to find this yellow area that if you integrate from a to b of 2x or f of x dx, is that going to give you that yellow area? Look back over there. What's it going to give you? It's going to give you the what? Opposite of your what? Area. Well, can't you fix it? So if you integrate this and you get -7, what's your answer? 7. So look at this. This is geometry. I'm gonna call this area 1. 1/2 base times height, right? What's my base? 1. What's my height? 2. So what's the area of this little triangle?
1.
What did we get a minute ago when we did it? We got 1. What happens if you integrate from -2 to 0 of 2x dx? I didn't make you do that one, but if you went and did that one, then what would you get? Well, what's this area? Isn't it 1/2 base times height? So what's my base? 2. What's my height though?
Negative.
Oh, is height ever gonna be negative? What's height gonna be?
Positive.
Just what?
4.
4. So what's that answer gonna be?
4.
4. Now, but this answer is not gonna be 4. What's this answer gonna be? Negative 4. That's what they're gonna make you do on your homework. They're gonna make you find an area and then tell them what the answer to this would be without using calculus. You see what I'm saying? Or they're gonna give you this and ask you for that area. Now, what's the one that's in your book though? The one in your book that we didn't finish, that's finished in the book, goes from -2 to what? 1. So look at that third thing I wrote up there. I can get this answer now. Why? Because what did I say? It's the area what? Above what? Minus the area what? Below. What was the area above? What was it? What was my area above? 1. Now, what was my area below? My area below wasn't -4, it was what? 4. So what's the answer to this going to be when you do your 5-step process? Look at the book. What did they get on page 309 for that final answer to example 2? They get what? -3. So using geometry, I'm going to be able to flip between geometric formulas and area and integrations. But I need you to cement in your mind, they're only synonymous. And what do we keep going to? The x-axis, x-axis. Now, the next chapter, they're going to go not to the x-axis anymore. They're going to expand it. Maybe you want to go between this curve and this curve, instead of the x-axis in this curve. But what we're doing today is like a little subset of what we're going to be doing. So what they're going to keep asking you then, look on page 310 in your book. I've got all 2 moments. Do you see example 3? This is what they're going to keep doing to you in example 3. A says integrate from 1 to 3 of 4 dx. Now, you can use the limit process that I taught you. Do you like it? No. If it said use the limit process, you would have to use the what? Limit process. What they're going to say now is use the definition of the definite interval. What does that mean? It means that 5-step limit process. So some of your homework is going to say this. All right, look at page 313. Have your hand on page 310 and look on page 313. You see number 7. It says in the directions, evaluate the depth interval by the what? Limit what? What's that mean? That 5-step process. Now, when I look at number 15, it says write a depth interval that represents the area of the region. Do not evaluate the interval. So look at 16. Now, if I really wanted that area, would I use calculus? What? No. But if they tell me I have to, well, then I'm what? I'm gonna what? I'm gonna have to. Wait with me? What integration would fit that? Is that curve non-negative? Then what do I know about the area of the integration? They are the same. So what would my A and my B equal on 16? What are my x values running from? 0 to 2. What's your f of x? What's your curve? Your curve is just what? 6 minus what? 3x? Done. They said, don't do it, just what? Write the integration. Now, look at all their little pretty pictures on 15, 16, 17, 18, 19, or all those non-negative. So what about those areas and the definite intervals? They're gonna be what? The same, but I might not do that. I might give you a curve that looks more like this. You know, maybe your curve goes like that. Maybe this is a 0, and maybe this is a 2, a 3. Is everybody with me? And they said, write an integration that's the area. So I'm gonna go from 0 to what? 3, or whatever the equation of that curve is, right? Is this gonna be the same thing as the area? What am I gonna have to do to fix it? My area will be the what? Opposite of that. That's what they're talking about. So if they don't tell you that you have to use calculus, use what? Geometry. So if they've got a big one, you might have to partition it to things you know. I'm gonna take this little piece because that's a trapezoid. I'm gonna use trapezoid for me. I'm gonna take this little piece because that's like a semicircle. I know how to cut a circle in half. You see what I'm saying? And chop it up. Where's your homework gonna be? Right. So next time we'll get the fundamental calculus, which will make life easy.